Hi all. In today's internet world, the information are travel from one location to the other locations. For example, while watching YouTube, listening audio in Spotify, or watching everyday activities through satellite channels, the informations like video and audio signals are transferred from one location to the other locations. But despite the advance of technology in the internet and increasing the bandwidth of transferring the informations, without certain mathematical algorithms, it's highly impossible for these functionings of YouTube, Spotify, and satellite channels. For example, in order to watch on YouTube with 720p resolutions, it requires nearly 1.6 megabyte per second of data to be consumed. And in order to watch full HD video resolutions in satellite channels or in YouTube, it requires almost 2 GB of data per second, so which is almost nearly equal to a, a limited capacity per day from Geo or maybe from Airtel. So how this possibility is happening with this limited data to watch a plenty of YouTube videos? So the mathematics behind the capability of watching YouTube is what this going to be this video is about. So for example, when we take an audio signal, for instance, just we record an audio signal for a certain time period, it might represent similar to the graph here. But when you try to put and try to transfer this pure signal in time space, it requires a lot of data to be transferred from one location to the other locations. But when we try to represent this audio signal in terms of frequency components, like at what frequency components are more significant for this representing these audio signals. In this example, a frequency about 8 hertz is more important compared to the all other frequencies from 0 to 120. So this kind of explanations is taken in terms of mathematics through these expressions. For example, in the previous one we saw that audio signal can be decomposed into different frequency components through these expressions. So this expression is representing a various frequency components, and this expression f of u is giving you what amplitude for this particular frequency components. So this linear combination of different frequency components weighted by these amplitude values gives you the original signal. Similarly, this what amplitude for the particular frequency can be computed by this inverse this functions. Maybe this direct function, or this may be inverse, or this may be a direct or is inverse function. So these expressions are termed to be called as Fourier transforms. Especially it's a discrete Fourier transform. And this is not only of audio signal, but when we're coming into terms of video signal, this is only example. But when we're coming to an image or a video signal, which we know that it's a two-dimensional one, so these also can be digitized and into a uniform grid of different densities, and those frequencies can be get along with a two-dimensional space along the x and y directions. So once we get those images in two-dimensional directions, similarly this function expressing the different expressing that particular image in two-dimensional space can be done by a linear combination of different uh, basis functions with different amplitudes, and those spatial frequencies are expressed by these functions. and those spatial amplitude is expressed by these functions, and the original signal is decomposed through these expressions. One in sense we wanted to know what amplitude for that particular spatial signals through the given signal, we can use this function to do that. So where do these fundamental equations come from? So the fundamental theory behind expressing an audio or video signal through frequency components is comes from a Fourier theory. So Fourier theory, what it says is, and every function can be expressed by a linear combination of Fourier basis functions, and those coefficients of the Fourier basis functions can be uh, computed through the inverse transform of the Fourier transform. So this, for example, only case. This is what a normal signal in a one-dimensional case can be expressed through different linear combination of frequencies in n-dimensional space, and that particular frequency can be computed from the original signal by these equations. So both are like a transform and inverse transform. So this is same applied to the 2D case, that spatial like in an image, for example, a two-dimensional image can be expressed by this linear combination of different spatial frequencies. So coming back to this one, so this is what two-dimensional things from that continuous is a discrete version of the Fourier transform for one-dimensional and two-dimensional one. So with this one, what we try to exploit is, we try to identify what are the frequency components are very essential for to represent that particular signals. For example, high frequency are normally are noise components with low amplitude, so those can be filtered off, and only the essential frequency are kept, which will be of a very low data bytes in terms of kbs, not in terms of gigabytes, and those signals will be passed from one information to the other informations, other centers, and that once it's retrieved, that algorithm will decode it and put it into the original. Maybe there may be a small loss, but not that significant loss. But the significance in gaining in compression and occupation of the memory and occupation of the bandwidth is significantly high compared to the in terms of loss. So this is a fundamental uh, thing thing going on when we are watching YouTube or Spotify or satellite channels. Not exactly, but the fundamental mathematics is what is happening. So instead of Fourier transform, what we does is normally discrete cosine transform is utilized, where only a real part of FFT is utilized for this data transmissions. So for a two-dimensional case, as we mentioned earlier, there will be a linear combination of basis functions, and what amplitude is needed for that particular things to be represented is expressed by these equations. And the reason for to choose DCT compared to FFT is that DCT requires a very low frequency components and essential frequency components, and decoding and putting back to the signal, the loss is very minimized compared to using pure FFT methods. So these are the fundamentals that just I wanted to discuss with you for today. But this is not a very detailed explanations for how the signal processing happening while watching YouTube's or Spotify or what. There are so many algorithms are there for representing an image like JPEG, representing an video signal like MPEG, or so many things. But but those explanations are what are the pre-processing has to be done before the discrete cosine transform, what are the post-processing has to be done after the mathematical algorithm. is beyond the limit of this particular video. That will be detailed possibly in future videos. Thank you very much.